Okay, so remember when we were doing the multiplication rule, we did talk about tree diagrams. Okay, so flipping 3 coins, you do all your branches. Okay, so we won't do the coin one because we have that already.
Wait, is it the blue book or the...
Blue book, yeah. Come on. Okay, box A contains 3 red beads and 4 blue beads. Box B contains 2 red beads and 3 blue beads. 1 bead is taken at random from each box. Draw a tree diagram to show all the outcomes. Okay, so box A we can either have red or blue. Okay, we put the probabilities up here. What is the probability of getting a red bead? 3 out of 7, and blue would be 4 out of 7. Okay, it's red or it's blue. It's one or the other. Now, if it's red from box B, I can then get red or blue. If it was blue, I could from box B get red or blue. Now, what's the probability of getting red in box B? 2 out of 5, and blue would be 3 out of 5, and it's the same down here. And then what you do is you read across the leaves, so that's red, 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 blue, blue, red, blue, blue.
Wait, so why is there 2 in box B?
Because it can happen that either you got red in box A, and then you can get either red or blue, or you can get blue in box A and then you can get either red or blue. Okay, so it's just the options. Now, red, red would mean 3 over 7 by 2 over 5. Red and red. You have to get one and then the other. And we know and means multiply. Okay, red, blue is 3 over 7 by 3 over 5. 4 over 7 by 2 over 5. 4 over 7 by 3 over 5. Okay, so you put in your outcomes, then you put in the probabilities.
Why does it go from 7 to 5? Yeah.
Because this is box A and this is box B. There's 7 beads in A, but there's 5 in B. They could be completely different things. It can be that it rains and doesn't rain, and then gets stopped at a traffic light, doesn't get stopped at a traffic light. It probably seems confusing because it's all beads, but it's two completely different boxes, so different probabilities. How would you get the probability that both beads were the same colour? What would you do? And what do you do with them? Add them, because it's this or it's this. So the same, if they wanted the same colour, you'd do red, red or blue, blue, which would be 6 over 35 plus 12 over 35. Okay? You don't have to do a tree diagram unless they ask you to, but often it helps. Okay? You could have just done this by looking at the question and doing your multiplication rules. So if it was the same colour, we'd be saying red, red or blue, blue. So the probability of a red is 3 out of 7 and a red out of the next one is 2 out of 5, which is what we have here. So you can just skip to this bit, but the tree diagram does sometimes help to lay it out in your head. Okay? Let's just do one other example of where things aren't replaced, okay? Can I get rid of the board? Okay. Okay. A box contains 12 beads, 5 are yellow, the rest are green. A bead is removed, they look at it, they note the colour, they put it back in. Or they don't put it back in, sorry, it's not returned to the box. A second selection is then made, and then a third. Draw a tree diagram and find the probability of selecting exactly 2 green beads. Can I get rid of the board? So what are my options? Yellow and green. Okay. Now, I'm just gonna clear this. Okay. Give yourself room. You need a bit of room so that you can easily see. Okay. So, the first, it can either be what? Yellow or green. What's the probability of picking a yellow bead? 5 out of 12. And what's the probability of picking green? 7 out of 12. Okay, now, if we've picked yellow, what are in the second selection, what are my options? Yellow and green again. Now, what's my probability of picking yellow? 4 out of 11. Because I've already picked a yellow and I've already picked a bead. What's the probability of getting green? Careful. I'm still only dealing, I've had one yellow bead gone. How many green beads have I left? I still have 7 green beads. Because I'm working off the yellow was picked here. So yellow is gone. Okay? So then I only have 4 yellows, 11 beads. But if it was green, I still have all 7 greens, but I only have 11 beads because that yellow is gone. Okay? Now down here, if the first selection was green, my options are yellow and green. Now, a green bead is gone. How many yellows have I left? 5. How many beads have I left? 11. A green bead is gone. How many greens have I left? 6. How many beads have I left? 11. Good. Okay. Now, if the first and the second was yellow, my options are yellow and green. Yellow and green. Same the whole way down, but the probabilities are going to change. Okay? Now, I'm here at this yellow. What's happened before this is a yellow was picked, then a yellow was picked. So what's the probability of getting a yellow? 3 out of 10. Okay? You had 5 yellows, then you've picked one, so you've 4, picked one, so now you've only 3. A yellow was picked, a yellow was picked. What's the probability of a green? 7 over 10. Good. A yellow was picked, then a green was picked. What's the probability of yellow? It was 5, so now it's 4. Good. Out of 10. A yellow was picked, a green was picked. What's the probability of a green? It was 7, so now it's 6. Good. Green, yellow, yellow. 4 out of 10. Good. Green, yellow, green. 6 out of 10. Green, green, yellow. So I haven't used any yellows. 5. But we have used 2. They were both green, so out of 10. And then green, green, green. 5 out of 10. Good. So my outcomes are yellow, yellow, yellow. Yellow, yellow, green. Yellow, green, yellow. So you're following it along. Okay, trying to hit each one of these. Yellow, green, green. Green, yellow, yellow. Green, yellow, green. And to get all the probabilities, you would multiply. Okay? So 5 out of 12 by 4 out of 11 by 3 out of 10. Now, the question was, draw a tree diagram and find the probability of selecting exactly 2 green beads. So where does that happen? Exactly 2. Yellow, green, green. Green, yellow, green. Green, green, yellow. So it could happen that way or that way or that way. So what will you do with your probabilities? Add them. Okay? So to get here, it's 5 out of 12 by 7 out of 11 by 6 out of 10. So that's 7 out of 44. And you're going to add all of those and you'll get 21 out of 44. These outcomes are not independent. They depend on the one before it. Okay? So when something is not replaced, it's not independent. Okay? So the first one was independent. It didn't matter what happened in the first selection. The probabilities didn't change, whereas these did change. Okay? Is that alright? Okay.